Okay, so welcome back, guys, to the second week of topics, the third one of your partial. Today, we're going to continue working with our topics, okay? And what are we going to learn today? Today, we're going to learn, before we go into the part of the variables expressions, we're going to learn about numbers. There's certain things that you do need to learn about numbers, okay? And we're going to learn them using a Venn diagram. And you're going to learn right now what a Venn diagram is. So we're going to place a blue one, a gray one, and an unfilled one. And we're going to place also an unfilled rectangle. Okay, this is what we're going to learn with a Venn diagram. So there is a whole bunch of numbers, okay? A lot of numbers that exist in the world. Any number that you can imagine, it exists over here, okay? Inside of that, okay, wasn't able to move it. Inside of that, we also have another group of numbers that are really big as well, okay? And inside of that, we have another group of numbers that we are also going to be working with. And inside of that, there is another group of numbers that we will be working with, okay? So there are different groups of numbers and that we're gonna call different family of numbers, okay? Now, inside of this, we're gonna begin with the smallest one. The smallest one, we're going to call them natural numbers. Natural numbers. And natural numbers are the ones that go from 1, 2, 3, 10, 11, 110, any number that you can imagine that is positive and that is whole numbers, okay? We're gonna, no, this is not natural numbers. This includes, sorry for that, this is whole number, sorry. Any whole number that you can imagine, that's the first family of numbers that we're going to have, whole numbers. And it begins in 1, okay? 1, 2, 3, 10, 110. All of these numbers are included inside the natural numbers, okay? Now, what's the difference about this natural and the whole numbers? That natural numbers include 0, okay? A 0 is not a whole number. It is a natural number. Then the rest is a whole number. So that's why whole numbers is inside of natural numbers. Then after that, we have another kind of family, which is called the integers. Integers are both positive and negative. So you got -1, -3, but you also have 0, and you also have all of the positive ones, okay? -44, -1,000. Any negative and positive numbers that you have are included in this, okay? So whole number, only the positive ones. Natural numbers, the positives, including 0. Integers, positive and negatives, including 0 as well. And all of this is inside another big family. Like I told you, we're going to make this a little bit smaller. And that is called the rational numbers. All of this, plus the ones that I'm going to add, are called rational numbers. Okay? And for example, a rational number is any number that you can write as a fraction. Okay, Victoria. Okay, so any number that you can write as a fraction is a rational number. So for example, 1/2, it can be written as a fraction. -3 can be written as a fraction if we place an invisible one at the bottom. Or we can have equivalent fractions, like for example, 4/2. 4/2 is +2, which I had over here, right? but I can also have an improper fraction, 41/2. Or I can have, for example, a decimal, a terminating decimal, like 0.37, because this number we can write it as a fraction, that is 37/100. But we also have another type of decimal, which is the repeating decimal, like 0.333 or 0.3 with a little bar on the top. That is also a fraction. That is 1/3. Okay, so all of those are rational numbers. But we also have another group of numbers that I didn't add. And that number is which one? The irrational numbers, okay? Just like we have rational numbers, we also have irrational numbers. So what's the difference between a rational and an irrational? And I'm making it big just to make it like similar to the one that I have in there. An irrational number is a number that you cannot write as a fraction. Irrational. And those numbers are, for example, number pi. You remember that we saw that number? Or, for example, square root of 10. It doesn't have a perfect root, and it has a repeating decimal that never ends, okay? It has a repeating decimal that never ends. So square root of 10 or square root of 2, or for example, negative square root of 5, or probably 0.1034035 and something that does not have a specific order. Those numbers are called irrational numbers. So you see how many families of numbers we have seen? We have seen the rational numbers that are made up of integers, natural numbers, whole numbers, and the rational itself, and also the irrational numbers, okay, which are the ones that cannot be written as a fraction. But all of these numbers that I just wrote in there, all of those are part of another family of numbers. Yeah, I know we have a lot of numbers of families of numbers, okay? We have a ton of them because besides this, we still have more. And all of this that we have in here are part of something that we are going to call from now on real numbers. Okay? All of this, both rationals and irrationals, are part of the real numbers. Okay? And real numbers go from negative infinite all the way to the positive infinite. When we say infinite, it's because there are a whole bunch of numbers that we cannot learn or tell or write because there are too many. But besides the real numbers, they do exist, the imaginary numbers. Okay? So imaginary numbers, I'm going to write them down here. I'm going to move this a little bit here. And like I was saying, we do have imaginary numbers, okay, that are not part of the real numbers. They're outside because they're imaginary. They're not real. And which ones are the imaginary numbers? Imaginary numbers. That's not written properly, right? Imaginary imaginaries. Imaginary. Is it with a Y or is it with IE?
With a Y.
With the Y.
Oh, it was written correct, right? Okay, imaginary numbers. Imaginary numbers are when you're trying to find the square roots of negative numbers. For example, the square root of -4. So I'm going to stop sharing so I can show you my calculator. Okay, and I'm going to spotlight myself. So this is my calculator. You can see there. So if I write, for example, the square root of +4, it gives me an answer. It says over here that it is 2, okay? It is 2. The answer of the square root of 4, it is 2. Now, if I place the square root of negative a number, can you see it properly? Square root of negative a number, and I do equal, it says math error. There is no calculator. There's still no calculator, at least that I know, that will give you the answer of a negative number, okay? There is no calculator that will give you the answer of a negative number. Let's continue sharing and I'll tell you why. Because I was telling you this is an imaginary number. So imaginary numbers are going to be written in this way. Pi is the imaginary number that stands for the square root of negative 1. The letter I is the imaginary number that stands for the square root of negative 1. So the square root of negative 4, it's basically the same thing as the square root of 4 being multiplied by negative 1. And just like we can join using the laws of exponents. The exponents themselves, we can also join the roots. So this means that there is the same thing as saying the square root of 4 times the square root of negative 1. Negative 1 inside the square root is the letter I. So this is the same thing as saying the square root of 4 times I, because the square root of negative 1 is I. And I just told you, there is a perfect root of 4, and that's what we're going to be working later on this week in the square root of numbers. So the square root of 4, like I was telling you, the calculator said that it was only positives, but it's actually positives and negatives. So right now, I'm going to explain you why it's positive, negative, and I'm going to explain you why later on, why we are only going to use the positives. It's going to be 2i. So the square root of negative 4 is actually positive, negative 2i. Okay? And those are the imaginary numbers. And the imaginary number that we're going to see is letter I, which stands for the square root of negative 1. Then after that, we're going to add the I to the second degree. And you're going to learn that I to the second degree is actually negative 1. So, but you're going to learn that later on. Questions so far? Do you guys have any questions so far? We good. Okay, so let's place the topic's name. What do you think after looking at all of this, and let's make this a little bit smaller. After looking at all of this, what do you think is the name of this topic?
Type of numbers.
Type of numbers, okay. That's a good idea. Someone else?
Rational, irrational, and imaginary numbers.
Rational, irrational, and imaginary numbers? Kind of, but no. Someone
Family
else?
of numbers.
I'm sorry?
Family of numbers.
Any of numbers? No. It starts with exploring. So all of you are kind of on the idea. Exploring. And I'll just make it small, exploring, real and imaginary numbers. And that is the name of your topic, exploring real and imaginary numbers. And we're going to continue working with this a little bit more because you need to practice, because all of this is important for what you're going to see in 10th grade as well. Questions so far? No? Okay then. this is the topic. I'm gonna leave it there so you can continue copying.